All right, we're going to solve exponent problems using logarithms, and I'll show you several examples. It most of the time follows the same pattern each time, but you do need to know the relationship between logarithms and exponents. Namely that if I have something with a base to an exponent, that's going to equal a number, and I can convert between that and logarithms because it's going to be log of the same base. But instead of in the parentheses, we're going to put the number, and the answer to the logarithm is going to be that exponent that was over right, here. That e is the same as that e, that b is the same as that b, and that n is the same as that n. So keep that in mind. You may want to make sure that you have that written down somewhere. I'm going to highlight it because it's going to be incredibly important, especially for this page. So the main idea is that when we're solving, we want to be sure that we get rid of everything in front of the exponent. So here I've got 9 to the power of negative 3x, but I have this 5 that's multiplying in front. Same thing here. I've got to get rid of this 3 before I can use this because it's 3 times this exponent. Essentially, we want to think about PEMDAS backwards if that helps you know what order. So the first thing we're going to do in each of these is we're going to divide both sides by 5. We want to get rid of the 5. And so it's 5 times 9 to the power of stuff. So divide by 5, and we are left with 9 to the power of negative 3x. I'm going to put that 9 in parentheses. And 20 divided by 5 is 4. So we got 4 because 20 divided by 5. Now I'm stuck. I don't know what to do, but I do have this really cool property. Some base to some exponent is equal to a number. So some base to some exponent equals a number. And I'm going to use the log to convert it to a log because then I'll be able to use my calculator. So we go converting. It's going to be log of the number 4. And the base is 9. And that is going to equal negative 3x. So I hope you saw that the base is 9, the exponent is my answer now, and the 4 is the 4. We just used this property up here to make that happen. And then in a calculator, so I'm going to put this into a calculator. I'm going to get some number for this. I'm going to put the log base 9 of 4 into a calculator, and I get 0.6309, and it keeps going a little bit more, but I'm just going to go out 4 decimal places. That equals negative 3x. And now our goal is to solve for x, so the last step is to divide by negative 3, and I'm going to get negative 0.2103 is equal to x. And so we've solved this problem. I'm going to go a little bit faster through the next one, but the same idea applies. We're going to get rid of the 3 on both sides because I don't want the 3. 64 divided by 3 is 21.3 repeating, and we're left with 6 to the power of m minus 2. I'm going to use my log property up here because I've got an exponent. I'm going to use this log property to convert it into a logarithm. So that's equal to that. I've got log base 6 of the answer from before, so 21.33 repeating, is equal to m minus 2. And I'm going to put this log base 6 of 21 and repeating of 3 into a calculator, and I get 1.7077 equals m minus 2, and we're solving for m, so we're going to add 2 to both sides, and it looks like we get 3.7077 equals m, and that is our answer. So we're going to try and just apply the logarithm, and what I mean by that is that we have our rule, or we have this property that some base to some exponent equals a number, and that's the same as log with a base of the same number is equal to the same exponent. And this is just the definition of what a logarithm is, and so knowing this property is going to help us again, once again throughout. So it looks like we've got the base of 10, an exponent of x squared plus 1, and it equals some number. So the first things first is that is in this format. So I'm going to just straight off the bat convert it into a logarithm because that will make things a little bit easier. So it's going to be log base 10, it's the same base, of 15 equals the exponent. The exponent is x squared plus 1. Now, I'm going to evaluate this log. So log base 10 of 15, or you could just say log of 15, is 1.1761. That's equal to x squared plus 1. And we want to get x squared by itself, so subtract 1 from both sides. So 0.1761 is equal to x squared. And to finish this off, we will need to take the square root of both sides, and we get x equals, take the square root of both sides, and we get 1.0845. And that's our answer. So the main idea here is that from here to here, it's using this property, and the rest of it is really just solving. Maybe you're solving a quadratic, or maybe you're solving a linear function. A few more. When you look at this, we're going to use that property again, although I'm going to think of this as base to the exponent equals some number, because this really is just some number. 5 to the power of 3 is really just 125, but we don't know that yet. Though I guess we do, because 5 times 5 is 25, and 25 times 5 is 125. So 4 to the power of x equals 125. That's helpful. Log base 4 of 125 equals x. And our calculator does these things really, really quickly. So all you got to do is put it in, and you get 3.4829 equals x. If you don't have a calculator, I'm sure that your teacher will allow you to leave it like this, but if you know how to use a calculator, that's even better. So I recommend you pause this video and practice some of the ideas that we just talked about so that you know that you're really ready to go. Desmos.com/calculator is a great way to use a calculator tool for these. So pause the video, and I'll show you how to do them in just a moment. Hopefully you've had some time to try these. Wanted to give you an opportunity to get started on them. So this, by default, we've talked about this in a previous video, has a default base of 10. So if there is no base, the default base is 10. And one of our goals here is to practice converting into log form or exponent form. So we're going to have to, this is currently in log form, we're going to have to convert it into exponent form. So you should have converted it into 10 to the power of 4 equals 10,000. And that's a true statement. And here we're going to have to convert it into a logarithm. So log base 2, because it's the same base, of 256. And we could check in a calculator that that actually does equal 8. Log base 4 of 256 equals 4. We're going to convert that into an exponent. So 4 to the power of 4 equals 256. And just so you know that this 4 is the base 4, and the exponent 4 is that 4. So they're related, but they're different numbers. And our last one, we're going to have to convert this into a logarithm. So log base 10, because the base of the exponent is 10, of x plus 2 equals 3. All right, we're going to practice again solving, writing as an exponent. So log, the default base here is 10. So 10 to the power of 0 equals 3x plus 7. Now this is really nice because anything to the power of 0 is 1. So 1 equals 3x plus 7. And this is just a linear function. So 1 equals 3x plus 7. We're going to subtract 7 from both sides. So that's negative 6 equals 3x, divide by 3, divide by 3, negative 2 equals x. And we could go check that by plugging that back into the equation, but I'm not going to have you do that for now. We're going to write it as an exponent, really just practicing. So if you want to pause the video and try these before I do them, probably a good idea. But 2 to the power of 4 equals x plus 5. You can put that into a calculator. 2 to the power of 4 is 16, so 16 equals x plus 5. And this is a linear function again, so 16 equals x plus 5. I should have just written it down there. Take away 5 from both sides. X equals 11. I hope you see that these are pretty straightforward to solve, so long as you know that you need to write them as an exponent first. So now they're going to get a little bit more complicated. I do recommend pausing the videos. We did these in class. But first step is really to convert to an exponent and then solve. So 2 to the power of 8 equals 30x plus 25. Use a calculator. 2 to the power of 8 is 256 equals 30x plus 25. Balanced move, subtract 25 on both sides. 231 equals 30x. I'm going to put that up here. 231 equals 30x. Divide both sides by 30. We're going to get some weird answer. 7.7 equals x. Now here, it's a little bit more complicated, but we need to use one of our log properties, and you may not know that yet. For now, when we can add them together, they actually subtract, so it's going to be, they multiply together, excuse me. But this is going to end up being log of negative x squared equals 0. And if you convert this, remember the base is 10, the default base is 10. This is 10 to the power of 0 equals negative x squared. And 10 to the power of 0, anything to the power of 0 is 1. Equals negative x squared. Well, you're hopefully going to see that we run into this problem because if I divide both sides by negative 1 equals x squared, and this is impossible. This can't be solved unless we have complex numbers, which we have not yet talked about. All right, one last time, I recommend pausing this video and practicing. I'll show you how to solve them really quickly. So I'm going to convert it to a exponent first. The default base is 10, so 10 to the power of 10 equals 9x plus 4. 10 to the power of 10 is a huge number. And so I'm just going to leave it as 10 to the power of 10. I'm going to subtract 4 from both sides. So I get 10 to the power of 10 minus 4 equals 9x, and we'll divide by 9. Divide by 9. So x equals 10 to the power of 10 minus 4 divided by 9. This is just a gigantic number, and so you can put that into a calculator, but the same idea applies. All right, the second one, it's an exponent. I need to divide by 7 because I have that number in front, so divide by 7 first. So we're going to get 2 to the power of x equals 189 divided by 7 is 27. Oop, this made it really nice. 2 to the power of something is 27, so what power of 2, or log base 2 of 27 equals x? And now we can put that into a calculator. And looks like x has to be 4.7549. And again, default base is 10. Looks like we can just convert it to an exponent. 10 to the power of 2 equals 3x plus 1. I need to, 10 to the power of 2 is 100 equals 3x plus 1. Subtract 1, so 99 equals 3x. Oh, that's handy. Divide by 3, divide by 3. X equals 33. All right, this covers all of the styles of exponent problems and logarithms that you need to solve them. I highly encourage you practice some more. Thanks for watching.